Hello everyone, welcome to day 3 of Arduino Week 2022. I'm Ubi De Feo, I'm going to be your host for the next hour. This is a day dedicated to community. We're going to have 3 guests. The first one is one of my favorite artists, Dries de Porter. He's joining us from Lausanne, Switzerland, and he's going to talk to us about how he uses technology to support his art pieces. It's going to be an honor for me to have him here. So, Dries, welcome to Arduino Week 2022.
Hello.
Ciao, Dries. So, how is it going with you?
Yeah. Very good. I'm currently in Switzerland setting up um, a new work and in the room where we're building up.
Okay, fantastic. I love these sessions where you build up your installations. Look, I mean, you're joining us. I'm super thankful for this. I want you to tell us something about your projects, whatever you want to share with us. I know that you have a presentation ready. Do you want to share a screen with us?
Yeah. I prepared
Okay.
a few slides to introduce myself and then about a product that I made with the help of Arduino. So yeah, my name is Dries de Poorten. I'm from Belgium. I see myself as a media artist. I work with technology, and most of my work is about surveillance, privacy, machine learning, and I make them in all kinds of forms. So it can be an installation, an app, a game, or also a product. To introduce myself, here are the 3 projects. I will be really quickly about this. So one of my apps that I made, this is already 3 years old. It's called Die With Me, and it's an app which you can only use when you have less than 5% battery on your phone. If you have less than 5% battery on your phone, you can chat to other people having less than 5% battery on their phone. And it's called Die With Me. It's pretty fun. You can see each other's battery status, and yeah, people with low batteries chat in my app called Die With Me. Another project.
I remember that project has been one of the most downloaded apps on the app stores.
Oh yeah, it was in after I launched it. It was 2 weeks the number one in the Apple App Store in the US for the number one. It's not that we have like more downloads than Facebook, but it was like trending for more than 2 weeks.
That's
And yeah,
that's
it's
amazing.
yeah. So this is an app that I made. A few months ago, I launched software. It's called the Flemish Crawlers, and in my government in Belgium, we have a live stream of our politicians that are meeting, and I made software to detect if they're on their phone. If they're too long on their phone, they got tweeted out. Like it's done a small video, dear distracted, the name of the politician. Please stay focused. And that happens all automatically with the help of machine learning. And the last project I want to talk about to introduce myself, it's called Quick Fix. And Quick Fix is a vending machine where you can throw in €1 and you can buy likes and followers for Instagram and Twitter, and you get them instantly. So currently, you have lots of bots. So if you order it through this machine, then the bots follow you and you increases your likes and or followers in a few seconds.
That's
So
amazing. Actually, there's a lot of technology in all of these projects, while the second one is a little more software based.
yeah.
The first and the second one, the third one has a lot of hardware to it. So it's a really
Mhm.
interesting project, extremely conceptual. And you may understand why I may say that Dries is one of my favorite artists. So tell us
Thanks.
about Short Life, which I own, by the way. I bought one of the first series, Short Life, if I
Yeah.
remember well. And please
Thank.
tell us something about it.
So Short Life is a product that I developed, and it looks like this. This is version one, and Short Life is a clock. and it shows a percentage, and it shows a percentage of your remaining life, um, of your life that is already completed based on your life expectancy in your country. So it's really personal. If you order it to my web shop, you need to fill in your age, where you've been born, and then it uses numbers from the World Health Organization to calculate what's the average age in your country. So it shows the number, the percentage of your life that is already completed. And there's like a small subtitle you see on the slide. It's called Short Life, a clock to remind you that life is short.
That's
For
amazing.
the So for the prototype, I use Arduino, and this is version 1. And it uses the same chip as Arduino, so it's a Mega chip. And I prototyped it, and then I developed my own PCBs, and that's how it got shipped out. This is recycled plastic, and on the back of the PCB, what you see here in this slide, is the name and the edition number. So I will only sell 1,000,000. So it's a limited edition. And the name of
Love
the
it.
person is written on the back. This is a bit. So this was version 1, and I had a lots of orders. Really awesome to see, but I had to solder everything on the board itself, and that took me lots of time. So I think every clock was like 40 minutes. So
Wow.
this is with all the components, and this is how I get from the factory. And I decided to make a version 2 where all the components are soldered on the PCB already, except the LEDs. And it also has now wood on the back, but this is only taking me like 5 or 6 minutes to assemble
Wow.
it. So it's really fast. But then after I made version 2, soldering didn't took me a lot of time, but then the whole like programming took me a while. This is version 3. Uh, this is something where I'm working on right now, where all LEDs are included on the board.
Wow.
Um, I have a few slides of the prototypes also. I don't know if you're interested in this.
Please, please share everything that you want.
Yeah, this is like the first thing I developed for short life. So first was on an Arduino, then I took all the chips from the Arduino, put it on a board, and try to emulate the Arduino. And it's a lot of testing. This is like me trying to connect to displays. You see also the Arduino there. So, uh, but then this is really a really prototype. And
Look,
then
I think that the fact that you share these slides is extremely important because, this shows us that our most popular product, the Arduino Uno, is basically something that helps beginners transition from an Arduino board to taking every
yeah,
component from the board and replicating. So this is the
yeah,
same learning experience that I had in the past. I mean, 15
oh
years ago or
yeah,
something.
it helped
So
me it helped me so much. So like first my for short life was really like first Arduino, trying to connect it to displays, and then try to put out all the chips on the Arduino, check what are you using, buy those chips, and then I put it on a a board, and without with the Arduino itself. And then the next step is then placing it all to a PCB.
yeah, it's the
So
learning experience because people should consider that you had never built any hardware before encountering Arduino.
no, oh no,
Yeah,
no.
so that's it's a
Um,
great case for the work that we're trying to promote.
yeah, yeah. Um, and maybe this is also interesting. So after I smoothed out the process of ordering the hardware itself, I spend a lot of time on programming them. So when someone order it, I need to change some variables in the Arduino code. But that took me a while, so that's why I'm now using the Arduino command line tool that you developed. I don't know
Yeah.
when you developed it. It's pretty young, right?
We started 4 years ago.
Oh, okay.
Yeah.
So this is how I program now short life. So it's like a small tool where you can it gets the information for my web shop and programming directly to my to short life. Or basically, short life is inside there an Arduino. So I just need to fill in the order number for my web shop. Then it gets
Yeah.
information from the World Health Organization database, and then it programs them directly. So this is an example where a guy ordered it from Belgium. The average age is 79, and then it programs it directly to the Arduino. I don't have to open Arduino. I don't need to change variables. That really
Yeah.
smooth out the process and makes everything faster in shipping the short life.
This is such a fantastic case for using a product that I personally worked on because it's my
Yeah,
team
I know.
developing that. I'm extremely proud of the fact that some artists and some creatives find interesting uses of our products that optimize their time frame. Okay, fantastic. Do you have something else to show us? We can maybe take some questions if we have questions from the user. Let's see. So I absolutely love your work. I will never stop saying that. So I'm very happy you decided to join us today.
It's an honor to be here, really.
Thank you. So it doesn't look like we have any questions for now, but I'm gonna wait a few more seconds. Do we? Okay. So let's see.
I think we have one, right?
Okay. Do we have the first question coming in? The question is, can you tell us about the design process for artistic projects like this? What is your process? I mean, it's kind of an articulated answer. So if you can sum it up.
Oh yeah. Whew, it's hard. I think for every project is a bit different, but let's talk about short life. To be honest, was just Corona hit in Belgium. Had lots of time, and I really wanted to do something with. Yeah, I think I really wanted to show that life is short for some reason. So I started developing this, and I already had this idea there, but I really don't want to. Like I was thinking about how can I change a clock? How does a clock look like? And it's just like starting testing out stuff, just changing. Yeah, I don't know where I am at right now,
No, I
but
get it. I think our users get it too. I mean, it's for you, it's a thought process, something that inspires
yeah.
you to
So
create.
most of the time, I'm motivated by the concept, and then it really, yeah,
Yeah,
I'm motivated about the concept, and then I start working on it, and most of the
this
time
is
I work on multiple projects at the same time.
yeah. I know that because we've known each other for, I believe, like since 2013. I went to check when we gave that talk together. We have another question from a student, which is quite interesting because when I met Dries, he was fresh out of school. A student wondering about time management asks you, how do you find the time to work on your projects well?
Uh, um, so when I was a student, I was really I had lots of time and I really used this to make projects. But now I'm doing this professionally. So I have my own company since 6 years and basically have an income of being an artist. That took me a while. So it was not an easy process, but I always keep on having for every project, there's like kind of a a business plan, let's say this. So I have time because it's my job now. And I
Fantastic.
think when you're when you're a student, you really have more time than when you have
Yeah.
a job.
Yeah. This is, I mean, this could go under life goals.
Yeah.
It's, I can imagine many young students who want to get into the art world. There is an art world as a profession out there. So you just need to put yourself to it. We have one more question, which basically
Yep.
kind of had an answer before, and it's how much of an electronic background did you have before starting?
Actually, I studied electronics for 6 years. Um,
Okay.
yeah, and then I went to an art school, and I really used my experience with electronics in this art school. It was pretty weird in the art school to have someone with an electronic background, but I fully used it in my art practice now.
Okay.
But I have quite a lot of um, experience with electronics.
Okay. Yeah, when I met you, you were doing mostly conceptual work. There's a connected question, and I guess it's going to be the last one because we're running
Yep,
past our time. And it's connected to that one. And how much of a software background did you have?
nothing. So in electronics, we didn't do any programming.
Okay.
And yeah, I just did electronics to getting into Arduino, and then I learned programming. I start with Arduino and processing at the same time, and now I'm using a lot of Python.
Fantastic. I love Python. All right, Dries, thank you so much for your time. Once again, thank you for being with us. Arduino is
Sure.
pleased to have had you here. I'll talk to you soon. Good luck in Lausanne with your
Yep.
installation.
Yep. Bye
Cheers,
bye.
mate. Ciao. All right, so now we have two community projects. We're going to showcase two videos, one after another, so stay with us. Two projects by Michael Kinsey, who's going to talk to us about robots, robotics, and art. Michael builds robots to produce art. And the second project is by Alessandro Perini, who uses electronics and code to support his work as a musician. So he's a creative person who built a clarinet that plays along the musician. Let's play the two videos. It's going to be a few minutes. Stay with us. There's a Q&A session at the end, and we're going to collect questions from the audience, and we're going to have live Michael and Alessandro answering your questions. So stay with us, just a few minutes.
Hello, my name is Michael Kinsey. I am a senior at Baylor School. Today, I will talk about the philosophy and processes behind my project for Arduino Week. I make art robots, and in order to understand this, I must give a Latin lesson. Do not worry, there will be no test at the end, there will be no questions. But I find it only fitting to finish off my senior year by teaching the lesson that was taught to me at my first day of high school. Today's lesson will consider the phrase amant victoriam curam. Many with basic vocabulary in Latin are able to translate it to mean roughly victory loves care, or something like that. I find this not to be a very deep meaning, but in order to truly understand something, we must look at its background. About 65 AD, a poet by the name of Gaius Viralis Catullus packed up his life and moved to Rome to make it big. Like most poets, he died at the ripe old age of 30 and became a part of the Neoterics, neo meaning new guys. They are known for abandoning the classical structures and themes of poetry in the hopes to write about daily life, like the beatniks from the 60s and other famous cool writers from around the era. They wrote about friends, travel, drinking, and sex, mainly sex. For Titalius, the love of his life, whom he mainly wrote about, whom was also married to another man. Titalius, his work as a whole can be described as solicitous. For those who don't know what that means, it means dirty, explicit, scandalous, vivid for me, and exciting. So let's say that dirty, explicit poems did not bode well during the monastic era of the church and the preservation of text in the church. The fact that we have anything of his at all is a miracle, because by the 1300s, there was only one copy of his poems left, and many say it is being used as a cork in the barrel of wine. And it is within the 60-second poem of this cork we found, a wedding song about two choirs, a boy and a girl choir, singing back and forth at a wedding competition for a prize. In short, the boys begin soppily, and then the girls come in and just crush it. The boys were realizing they had been defeated, sing roughly, "We have sent our brains in one direction and our ears in another. Amant Victoriam Crum." So what? Why is this important to what I do as an engineer, an artist, a person? It's important because, in short, the success you witness is dictated by the effort you subscribe to a task. That means, well, if you want to do well at something, you have to do it fully, totalmente, with your whole mind. So if you want to do well on a test, you should probably study. When you turn in a piece of writing, you should probably check your citations. And it's important for my project because over the past 7 years, I've spent countless hours over the years learning about art and science. And only now am I able to hone it into something meaningful and unique that I think it's really cool. And it is making robots that are able to create generative drawing. And the one I'm working on right now that's going to be submitted for the Arduino week is an R3 planar robot. Its main issue is how I framed the project. I wanted to try to replicate Verna Molinare's generative drawing, but using a machine, which is way trickier than I ever thought it would be. But for the most part, and what I'd like for people to see and get from this, at least, is if it is not done with love and joy and happiness, then it isn't worth doing at all. Amant Victoriam Curum. Thank you.
Hello, I'm Alessandro Perini. I work with sound and music. I studied composition, electronic music, and technologies of sound in Italy, where both Arduino and me are from. And in 2009, I moved to Malmo in Sweden, and I'm still here. I'm presenting from InterArt Center, which is a hub in Malmo for interdisciplinary arts, and is a place also where I work as an artistic supervisor for sound and music projects. And also it's where I work on my own artistic projects. So I work mainly with sound and music, as said, and in fact today I'm going to show you two projects in which I modified musical instruments in order to activate different ways to perform on them. So the first project is a modified clarinet. I play clarinet since I was a kid, and since the beginning I tried to experiment with the instrument, trying to find, for example, unusual fingering combinations so that I could produce sounds that would sound weird to me. And now I'm a composer, and I decided to write a piece with this kind of experimentation. And to do that, I decided to motorize, thanks to Arduino, 2 of the keys of a clarinet. So what did I do? I 3D printed in nylon powder a sort of case that can be attached to the central part of the instrument. Why nylon? Because I tried with PLA, but then the 2 solenoids that are hosted in this structure got so warm that the PLA started to warp and to melt. So after building this, then I decided that I would write a composition. So a composition where both the human intervention on the instrument and the robotic intervention would happen at the same time in a synchronized way. So I used the Reaper, which is a software for music making. I had different streams of information. One stream was the score that the clarinetist needed to read. So it was kind of a scrolling score, like in the video game Guitar Hero. And the second stream would be MIDI notes that were actually sent to a max patch that was translating MIDI notes into serial commands. And these commands were sent via serial to an Arduino Nano. So the Arduino Nano then was making these solenoids push the 2 keys of the clarinet. So what did I achieve with this? Of course, you can experiment with awkward fingerings because these 2 keys are usually operated by the right hand of the performer, but the right hand is used for the lower part of the instrument. So these keys are actually keys that you use only in special occasions, where when the left hand is only operating the upper part, and then your right hand is free to work on these keys. But then what happens when you are able to operate on the lower part of the instrument as well, and Arduino is pushing these keys for you? Then you can reach special fingerings that create unusual sounds, unusual pitches. And you can also reach very high speeds that are impossible to achieve for a human finger. And also you can work on the keys with different tempos, so towards a polyrhythmic music. I am a terrible clarinetist myself, so I will not play the piece for you, but instead I will show you now a fragment of the performance by Natalie Eriksson, so you can get an idea of what happens in the official recording of the piece. And there is a second project that I wanted to show you today, which is a modified electric guitar. In this electric guitar, I inserted tuning pegs that are motorized. So they are actually very small servo motors. And to do so, I bought these commercial motorized pegs by Tronical Tune. These are motorized pegs that are used for automatic tuning of your electric guitar. So you just select a configuration, a tuning, and then you strum your guitar, and there are pickups that are listening to the strings individually, and then the motors are acting so that the strings are more or less tense, and you achieve the tuning that you want. But then I got rid of all the brain of the system. I only kept the motors, and I connected them. You have to solder very, very small wires, and then you can connect it to a servo driver board and then to Arduino. And then you can finally control it with a computer. And as I did with the clarinet project, I had a Reaper environment with a scrolling score, and I had MIDI notes translated into serial commands sent then to the Arduino. So what happens when you have motorized tuning pegs that are modifying the pitch of your strings while you are playing? Of course, it could be annoying if you play rock music, but in my case, it was a lot of fun, and you will see it in a few moments. You will see my guitarist friend Ruben Mattias Antorsa produce some unusual glissandos. For example, he's playing natural harmonics on the strings, but those strings are also sliding upwards or downwards, and that's very difficult to do unless you play on the guitar and then go to manually operate the tuning pegs. Also, you can have independent glissandos in 3 different strings, independent in speed, but also independent in direction. So you can have one string going down and one string going up at the same time. So now we'll show you a fragment of this piece. Okay, so in case you feel inspired by these experiments and you want to apply them maybe to a different instrument or to a different object even, you can look for some tutorials that I wrote on the Arduino Hub website. Just search for motorizing a B-flat clarinet and in the guitar case, hacking auto-tuning guitar pegs for Arduino and MIDI control. So for any question, you can also reach me on Instagram. My handle is touchmysound. Or you can just ask me something in the few minutes that we have reserved for our Q&A time.
And welcome back. Thank you so much, Alessandro and Michael, for showing us your projects. I am very impressed as usual. We have some incredible makers in our community. Michael is joining us from the US. Alessandro, I guess you're in Malmo still? Yes. All right, fantastic projects. Thank you so much. I have to say I'm impressed by the young age of Michael. The drawing machines are a thing of mine. When I used to teach in Copenhagen, we did a whole year of drawing machines. So I love robots that produce visual output. Fantastic work. Alessandro, your work is impressive. No need to add more than that. We have a couple of questions from the audience. One is for Michael, one is for Alessandro. I'm going to start with Michael. The question from the audience is, how can technology positively affect art from your point of view? You are very much drawn into poetry and art, I can tell from your content. So how can it affect your work? How can technology affect art?
Ooh. Well, first off, can you guys hear me? One. Yeah? Okay.
Yes.
Good. Great. Okay, that's hard. It's really hard. I would say that technology absolutely can and does affect art almost every day, not only with how easy it is to view large quantities of it, but how easy it is to help generate art. Because traditional methods of art, you had to sit there with a paintbrush and look at it and measure. But now, if you have a projector, you can just project whatever you want to paint onto a canvas, and it expedites what you want to do as an artist. And as a viewer, it also expedites finding things that you really like. So that's kind of where I'm at right now with it. And there's a whole lot you can do with technology in art, especially with drawing machines like this one. I mean, I'm working on trying to implement ROS onto my current drawing machine, which is a pain in the butt. But that's about all I got.
Okay, thank you, Michael. I'm having some issues with audio. I can't really hear much, so I don't know if the audience gets it. We have some echo. Sorry for this. Michael, maybe it's your computer giving us some feedback. Can you try and lower your volume and see if it gets better? Sorry, that's.
Can you guys hear me now?
Yeah, we still have some echo. I don't know where it's coming from. It's all our microphones are off except this one. So might be a streaming thing. Yeah, it's really. All right, I'm gonna move ahead and I have a question for Alessandro. Well, first of all, it's a comment that says, "That's so cool. How did you translate MIDI stream to serial to command solenoids?"
Hi everybody, yeah, that's quite simple actually. So I've been using MaximSP. It's just a software that a lot of people in the sound world use for live electronics or controlling anything from video to sensors to actuators. And it's quite simple. It's just a small patch where stuff comes in as MIDI. So from Reaper, I send the MIDI directly to MaximSP, and then there are just some mathematical operations just to make it into numbers that Arduino can recognize. And then there is an object in MaximSP which is called serial. So it just sends like raw data via serial. Maybe I can also try to share my screen. Let's see. Yeah.
I don't know if you're. Okay, yeah.
You're seeing, yeah, this is the patch. I don't know if you're seeing that. Can you confirm
Yes.
this? Yeah. So this is the object note in, the one in the middle, in the upper part is just listens for MIDI notes, and then here is just some list processing. So at the end, what you will send to Arduino will be into this serial B. B is the port, and this is the baud. And here you have, I'm sending 1 and 2 for the first motor, so 1 is probably on and 2 is off. And actually, yeah, 1 is the motor and 2 is, 1 is one motor and 2 is the other motor, and 11 is the off for the first motor and 22 for the second motor. So that's how it works.
Fantastic. I love MaximSP. I remember I bought my first license many years ago and I kept upgrading because it's a fantastic piece of software. The project deserves support. One more question for Michael, actually. One of our users asks, were your projects created for art classes or engineering classes?
All right, let's see if we can do this without echo. The art robots themselves were created in my AP 3D art class, but I'm also working with an ROB Slam and LiDAR robot in my engineering class, which has been a whole lot of fun, especially taking what I learned from each one and trying to combine them to work more efficiently. Yeah, that's it.
Okay, awesome. We have one more question for Alessandro. Are you planning to do something similar for any other instruments? Could this become a whole automated orchestra? Beautiful question.
I focus a lot on solo instruments because this project just go to intercept how the mechanics of the instruments work. So they create a very special way of listening, which is also clashing with what you see. So you expect a certain instrument to deliver a certain sound, but then there is Arduino, there is a motor that changes what's coming out of the instrument. So I think the listener should be really focused on one instrument, or maybe two, or maybe three. But an orchestra, I think, will be a little bit too much. And yeah, I mean, I applied this stuff to clarinet and guitar. I did some projects with some other instrument. Maybe I can continue sharing the screen so you will see some other tutorials that you find on the Arduino Project Hub. So this is since I saw also there was a question about can flutes be played via Arduino. So in this case you have a melodica, or yeah. So there is a compressor that spits, blows air into the instrument. So the flute could be played in the same way. Of course, then you need some other model that will push the keys of the flute. And then I guess you can see here there is a project with piano, with vibration pianos, vibration motors that are making the piano strings vibrate, and then there is a performer picking up the resonances with contact microphones. And then there are some other projects that are not directly related to music, but more to sound art. So there are installations and some other stuff. But yeah, I'm continuing exploring this subject. Sorry for the video feedback. I will try to. Yeah, thank you.
Your project tab is extremely interesting. There are so many beautiful projects. If you want to look in depth what Alessandro is building, just go to Project Tab, look him up, and you can replicate the work that he has done. Thank you so much for sharing with our community, Alessandro. It's I know how hard it is to document a project such as yours. So fantastic. We have one more question for Michael. I still hear myself a little bit of echo, so I don't know how it is for the audience. But Michael, one person from the audience asks, what should I study to do this, electronics or software? Which is most important for making this kind of project?
For generative drawing, I would study software because a lot of my art is based off of Verna Moyer. She is a software developer who creates generative drawing, and if you can learn how to code that on software, it'll be much easier to implement it into some kind of physical system. Where I went the other way, where I started making physical systems and then learned how to code and develop the code that will make it random.
Fantastic question. So in the end, you might want to study both, but you know, you will start. I think once you start from software, you get inspired, and this is transition that many artists make, which is they transition from the screen to the physical world, which gives it that additional depth, or you know, the sense of touching something. All right, so we are done with the questions. Okay, Alessandro is still there. Fantastic. Thanks Thanks, Alessandro. Thanks, Michael. We are going to say bye for now, and we're very pleased of having you as our guest. Thank you so much for aligning your schedules with Arduino Week. So by the two of you, I'm going to just announce that we are at the end of our first segment, our first hour. So we're going to stop now. We are coming back at 5 p.m. Central European time. So we have a 1 hour break, and we're going to start with another great artist, Smith&Lyall. Anna is going to interview him, and the next session is basically spearheaded by Anna and followed up by our very own Keith. Thank you so much, everyone, for being with us. It's been an exciting 46 minutes. I am extremely proud of the work that we can showcase for our audience, and I'll catch up with you guys soon.
Hello, welcome back to the Arduino Week. I'm Anna, and I work into the marketing team. Today I'm here with my colleague Kit, and welcome to the second part, actually, of these talks of today. And today we will explore different projects and applications of technology from art to sports, passing through robotics, coding, and IoT. But now let me introduce our guest for today. His name is Smith&Lyall. We are very, very happy to have Marcus with us today. He is a great interactive artist and co-show director for Chemical Brothers, just to name one. And Marcus, welcome to the Arduino Week 2022. How are you?
I'm very good. Very nice of you to have me. Thank you very much.
So in this session, Marcus, we'll go through the process of how technology can, let's say, collaborate with art, and also how humans and human interactions can create valuable art and valuable interactions for different kind of projects. But first, I'd like to show a video about one of your latest works, and then we can go through our interview and conversation. That's amazing. Do you want to say something on this work?
Well, this is from the Chemical Brothers live show. Myself and Adam Smith, who's my creative partner, we've been doing that show for some time. Adam's actually been working with them since they pretty much started in about 25, 26 years ago, and we've been working on and off on it, certainly on it for the last 12 years or so altogether. And it's sort of gone from being this kind of, a sort of very much grassroots rave kind of thing to this kind of epic festival headline show where, and it's been quite incredible, really. It's sort of going, literally, when we started out doing it, we were using 16mm cine projectors and slide projectors, and now we're at the point of having sort of lasers, lighting, sort of 15 to 20 meter wide LED screen, so it's something that's been built very organically over the years and just sort of grown and grown and grown, and we've sort of been quite sort of shocked by the fact that it's kind of reached the level it has, and you know, it's been very inspiring working with Tom and Ed, because they've kind of given us carte blanche to really get on with it. They kind of give us the music and say, make some stuff, and we show them ideas, and they say, yeah, that looks good, let's do that. And we've done some really crazy stuff, and they've just kind of given us a lot of trust.
Wow, so impressive, super cool. So Marcus, you often use data and technology to represent people's emotion and let's say connect an intimate dimension. And the first question is, which is the relationship between art and technology in your projects, in your artworks?
Well, I think, I mean, in a lot of the artworks I create, I like making, using a lot of the kind of stage technology that we use in big concert shows, and then essentially allow the audience to control them as a sort of one-on-one experience. So suddenly you go from sort of, there's quite a difference between, for instance, in this piece, the slides up at the moment, this piece Presence, we put a laser at the end of this. It was like sort of the area under a dual carriageway, like a motorway that was raised off the ground, and we used the area underneath and created this kind of this window that had a laser sort of along about 100 meters, and you controlled it with your voice. So you literally used the foot pedal and sort of shouted into the void, and then this huge tunnel of laser light would appear, and your voice would be echoed, and your voice would sort of, so the laser was controlled by your voice. So it's about sort of trying to give control of these very sort of monumental sort of light creations, light compositions over to the audience, so that they can sort of play with them. I mean, part of what I do is I like collecting data from people, so sort of making performances from the audience's data and getting them to think a little bit about what happens when they hand their data over to people, you know, to Google or to, I shouldn't sort of single them out because I'm using Google Slides all the time, but in general, there's and so that can be quite intimate. You know, I did an installation so further on in the slides called On Your Wavelength, where we used an EEG headset, and basically here we go. Yes, this one, and so here you wore an EEG headset, and it could basically monitored your brain activity. And we programmed everything so that depending on how concentrated you were, the music and the lights would react to what that was. So if you concentrated more, you could get something that was a sort of more a sort of faster and more sort of melodic soundtrack, and the lighting would go sort of brighter and whiter. And as your thoughts became less focused, then the lighting and the music would do the same thing. But then you sort of start thinking, I'm just this artist, and people are kind of giving me access to their brain activity. It's quite weird, you know. And so thinking about how we might do that in other places in our life and not maybe think too much about it.
Yeah, and it's so impressive how you, let's say, use in a positive way people to make a piece of art. I mean, your art is very like, you can touch the presence and the contribution of people, and I guess different people with different also attitudes in interacting with your operas. So that's very impressive, and I think it's a very good start for a super long conversation.
Yes, yeah, a bit to maybe yeah, it's, I mean, it's I think it's really, people see a lot of these things but don't get a chance to actually make them. It's really fun when you have some control over them. You know, it's a bit like amplifying your personality, isn't it? That you kind of get some of the feel of what it's like to be on stage. And I guess that's kind of part of what's really nice about doing these things, is seeing the reaction, and there being this kind of this context where people feel like they can do something they wouldn't do in normal life, like shouting into a tunnel or screaming at their laptop to light up a building, or doing different things that maybe take them out of their sort of ordinary lives.
Yeah. Yeah, so true. And let's talk about music. I mean, you've been working with a lot of super great bands like Chemical Brothers or Deadmau5, and the $1 billion question is, if you could choose a band from the past or from the present, a band or a solo artist, what would it be, and what will you do with this band?
Oh, I mean, God, where do you start? It's when I was younger, I used to be a big fan of Herbie Hancock, and I'd still love to do something with him, because I think, you know, we sort of draw quite a lot of inspiration from that sort of 70s sort of early synthesizer kind of period. And I saw Herbie Hancock play live once, and it was unbelievable. You know, he did a sort of set that was all of his kind of 70s synth stuff, and then a grand piano thing where he just sort of did Maiden Voyage by himself on the piano. You could have heard a sort of pin drop in the concert hall. And there's something, I guess, keyboards are sort of, and that idea of synthesizing, being able to, I mean, like with something like the Chemical Brothers, it's very sort of theatrical. We film everything. We kind of make it into very much a like a theatre musical, really. And I think the thing that's really nice about jazz is the improvisation. You know, the fact that making something where you don't really know what it's going to do, that maybe that the visual synthesizer you make kind of could end up doing something really unexpected, and something that you're not kind of fully in control of. There's something very nice about sort of something where you can't predict what all the results are going to be.
Cool. And the other question is, I guess a lot of musicians are watching and listening to this talk. So the question is, when you start working with music for musicians, which is let's say the first connection you establish to produce something else? Because probably, I guess, you start from music, but in the end, what you do is something that's three-dimensional, something very expanded.
Expanded, yes. That's we love using that term, expanded cinema, to describe what it is we're doing. It's I guess it has to come from the feeling of the music. I mean, that's what you're always trying to do, really. Is that's what music's all about. It's all about feeling and emotion, and so that's always the start of what is it that how do we want the audience to feel, and what does the musician, and importantly, it's always in service of the music when we do this kind of work. So what does the musician want the audience to feel? How can we support that? How can we make that? How can we amplify those feelings in a really sort of, you know, the thing about concerts is there's a lot of visual noise. There's a lot of things going on. So you have to be very clear and very sort of, you have to make it easy for people to understand what it is that you want them to feel. So for us, it's very much a sort of reductive process of trying to go, okay, let's have the smallest number of elements that get that across, and then try and make them as big and as exciting, and get as much kind of contrast and as much sort of roller coaster in there as much as we can.
Cool. My last question is, we've been talking about people that are a very big part of the interaction in your works. We have been talking about music. And of course, the third guest of our conversation is technology. And my question is, are you somehow or sometimes driven by a specific technology that's triggering you, or technology is just, let's say, a surrounding that is there to help you and express something that's, again, more expanded or extended?
I think it depends on, with concerts, it's a bit of there's always a sort of, how can I put it? I guess so to start with the artworks are in some sense about technology and our relationship with it. So there's always a connection there for sure. It's because part of what I'm interested in is the way that our relationship with technology, how we use it, how it uses us, that whole kind of interplay. In terms of as technology as inspiration, certainly for the music thing, sometimes, you'll see something and go, wow, I want to play with that. And I want to explore that. And we get the chance to do it. And it might be, for instance, we started working with motion capture a while back, which is amazing, because the idea of being able to capture human performance and then drag it into these kind of more abstract kind of animated worlds, amazing. And so something like that's definitely an inspiration. But also, I guess, I don't know, trying to be inspired by technology from lots of different periods as well. So a lot of what we do on the Chemshows, for instance, is using techniques that people were using 100 years ago. Sometimes, it's actually, a lot of it's really quite basic. But there's definitely a fascination with it, obviously, as it is with the music.
Yeah, I think you used a very interesting word, that's playing with technology, because you usually play with an instrument or you play just for playing purposes. But playing with technology, I mean, it gives me the image of someone that's really using a lot of tools. That could be an instrument, that can be a technology, an old technology. So it's super interesting what you do. And Marcus, thank you for this conversation. I think we have some questions for you. And let me check.
In the control room? Is this?
So a comment for you is, will be good to hear your thoughts on privacy discussion. Reminds me of Wade Kerr's face stealing tech at Aphex Twin shows, where audience members' likeness are manipulated in real time. So what do you think?
That's great. That's great. And Nikki Weirdcore, who's I've worked with on a couple of, who's absolutely fantastic, and has yes, it's I think and Nikki is another person who absolutely loves playing, and for him, I think the whole aesthetic of that show is very much about. It's nice when you see all the sort of broken edges and things not quite working, and sort of it's got a really kind of lovely aesthetic. And I think I think anyone who's sort of involved in both technology and art looks at the sort of more dystopian elements of it, and we're on a bit of a seesaw, aren't we? And I think his stuff's fantastic.
Cool. And one other question I'm looking at is basically which was your career path? If you could tell us something more on how you became and you do what you do.
I was sort of quite varied. Basically, when I was a teenager, we used to put on parties and club events and things, and again, we had like sort of really basic visuals. It was literally like my dad's slide collection and a sort of couple of carousel projectors, and then sort of buying old Super 8 projectors. And we hooked up with the Mutoid Waste Company when I was at art college, and started doing projections at some of their events, and then got it kind of built from there. And as I say, we were kind of part of that whole 90s rave thing of just kind of putting on sort of these sort of psychedelic film shows at illegal raves and clubs and things, and it kind of built from there. I've sort of been variously worked in multimedia, and I was a video editor for a long time and directing commercials and lots of different things. But the backbone has been sort of going from these club visuals to bigger concerts. There just weren't that many people doing it when I started doing it. There really weren't, and I was really fortunate in meeting some people quite early in my career, and sort of was like, oh, do you want to do U2's show? And it's like, yeah, that sounds. And then do you sort of, and it's like, oh, you've worked with U2. Do you want to do the Rolling Stones? It's like, yeah. And suddenly you kind of find yourself, doing all these. It was kind of surreal, really. Very fortunate that we were just in the right place at the right time.
Yeah.
Marcus, it's Keith here. I've just got another question, if that's okay.
Of course.
It's kind of a follow-up one, and it's asking how the process has changed from when you first got started with creating live shows, and whether it's easier now or is it more complex?
It's different. It's so much more controlled. I mean, basically, the way that it used to be, it was all very improvised, and you had very little control over things like if you we can cue everything to the millisecond now, and every element. So lighting, video, lasers, we can basically run the entire show and have everything controlled from a push of a button. Whereas if you can imagine when we started out, the way that we would change a cue on the screen would be, we'd have like 3 16mm cine projectors, and there'd be 3 people turning those ones off, and then with some other people, us turning some other ones on, and sort of then taking. It was very, very analog, and sort of and a lot of fun, and sort of very improvisation. Lots of improvisation, and everything's just got hugely more powerful, brighter. I think it's the real difference now is that, excuse me, when we started doing everything was quite dark. You didn't have a lot of light. You could have a little slide projector and it would light up the room. Whereas now everything's become sort of weaponized. Everything's incredibly big and bright and intense, and which is great, and it's just got bigger in scale as well. You're sort of suddenly walking in and there's a sort of 20-meter, 30-meter wide video screen. You're like, just enormous.
Cool.
Great.
So I think we are at the end, and thank you very much, Marcus, for being with us, and for everybody who wants to stay in touch, Smith&Lyall, and thank you.
Yeah. Thank you very much for having me.
Great. So I've just got to say, I mean, I've been very fortunate enough to see Marcus's work live when I went to the Chemical Brothers show, and it really is breathtaking. So if you get the chance, go along to one of his shows. I'm sure you'll be amazed. So just a quick summary of what we've got coming up in the rest of today's show. We have Jeremy Ellis, and he's going to be showcasing the Portenta Pro Community Solutions Library, which is some great work. And then we've got Noé Lamelli, who's going to be demonstrating Strider, a personal running buddy. Having seen the video, I should say Peloton beware. They've got a rival. Without further ado, let's lead up with Jeremy to walk us through the community libraries he's developed for the Portenta.
Hello, Jeremy Ellis here, maker of the Portenta Pro Community Solutions Arduino library. We'll work on any of the Arduino platforms. The point of this was, and while we're waiting here, I'm just going to show you what's loaded up here. Portenta Pro Community Solutions .hello blink. That's this program, and I'm going to fire it to. You got to make sure you're on the right board. I'm on the right port, and let's fire that off. Okay, so we're using the Portenta H7, but most of these this code could work on the Portenta Lite or the Portenta Lite Connected. The reason for it is the Portenta is a little bit more advanced than some other Arduinos in that it can also run embed code, and that created some issues because when it first came out, there weren't a ton of examples. And so what this is just a ton of examples. But one of the first things you should always do, check the port, go back to serial monitor, and make sure A, it's blinking, because this code is supposed to blink, and B, it's writing to the serial monitor. If that works, then your basic setup is working. And here's your basic setup. And here's your blink. Notice with these boards that low is actually completing the circuit for the onboard LED. And so the light goes on with low, and that's one of the things that's slightly different. Why I started using the Portenta is I teach a robotics course. The new version with the Portenta is called Maker 100. And 2 years ago, here's another GitHub site. 2 years ago, I started working on examples. And then I made a ton of examples, but I eventually figured out how to make a library. And so all these examples are in this library. And if you go to the examples, and there are a ton of examples, and these are all simplified. So your first one, when you first get the Portenta, you can run any of these. Okay, you don't need accessories or anything. There are some utilities, embed. This is pure embed programming, which is one of the advantages of the Portenta, is you can do embed or regular Arduino programming. Here we have some RPC to communicate with the core, but I also have a few, let's get back there, of my way of communicating between the cores. And these are just brand new, and they are able to use just the Portenta. Very fancy there. We have sensors, a whole bunch of sensors. We have actuators, your servo, PWM transistors, stepper motors. You can read through all these things. Pretty easy to install. I just go to the Arduino install library and type community. And then typically the second one is Portenta Pro Community Solutions. So here, say you've bought some of the shields. So there's an Ethernet Vision Shield and a LoRa Vision Shield. So here's Ethernet, a specific web server. And I've got an MQTT Ethernet broker going. It's not the most stable. Here's LoRaWAN. And recently I just got pure LoRa. And pure LoRa brings up some interesting things where you don't actually need to connect to the TTN or Helium network. More stuff on this. If you purchase the breakout board, I've got some programs that are specific for the breakout board. Now, machine learning, this is my area. I have my own version of doing machine learning, but I've found Edge Impulse is ridiculously easy. Kids learn in 40-minute class, learn how to do these things. So I've got simplified. Now I've simplified what Edge Impulse has, and Vision, Vision with an OLED, Vision with Helium, MQT. We've got a couple advanced things. This is recent. This is using the SRAM to very quickly interact between the two cores. Here's my coding curriculum, which I have videos for. I should include the link somehow. Here are the videos on. This is just basic C++ programming, the main things I teach when I'm doing C++ programming. Let's get back in there. And community solutions. So I was on my curriculum. So strings, simple variables, for loop, arrays, structures, and then this is for gotchas, and I haven't done much there. So nice talking to you. I hope you enjoy it and curious about any questions.
Hello everyone, my name is Noel Lomeli and I live in Soquel, California. It's an honor to be here and be able to present my project. I have a bachelor's in computer science, so during the day I work on web and app development, but on my free time I enjoy working with Arduinos. To me, there's just something magical about being able to write code and then see something come alive in the physical world. So without any further ado, let's dive right in. Strider is a personal running pacer. One of its main functions is to help you improve your running speed. The way it works is that there's a mobile app where you can enter the information and tell it how fast you want to run. So for example, if you want to run a mile in 7 minutes, you enter the information, which then is going to be sent to the Arduino. The Arduino is going to calculate how fast you need to run, and then all you got to do is follow it. The best part is that there's no remote control that you need to hold. You control the car by running, stopping, turning towards the left or towards the right. Here you see the components that I'm using. There's the Arduino Nano, which controls everything else. It's located right here. In order to communicate in real time with the Arduino, I have a mobile app, and that's where the Bluetooth module comes in. The microservo is located in the front, and it's responsible for steering left and right. There's an electronic speed controller that allows the DC motor to speed up, slow down, stop, and go in reverse. Lastly, there's a camera in the back, which is right here. Its purpose or its job is to keep track of the bright orange square here in the vest. It's always sending the X and Y coordinates to the Arduino. Now, the main component in the code is the proportional integral derivative controller, or PID for short. To give you a brief overview of how it works, the X and Y coordinates get sent into the PID controller, where the error term gets calculated. When the person is standing right behind the robot, the error term is 0. So that it gets multiplied with P, I, and D variables independently, which then gets summed up. This result gets sent to the control variable, and this allows the robot to know whether to turn left, right, or continue moving forward. Also to speed up and slow down. So if the person was to move to the left, then the error term would be non-zero. This number gets multiplied again with PIDs. Again, it gets sent to the control variable, and then the car knows that it needs to move to the left. Once it gets recentered, the error term goes back to 0. If the person goes in the opposite direction, same thing happens. The error term is non-zero once again, and the same thing goes repeats. So that allows the car to always recenter itself according to the position of the person who is wearing the bright orange square. I came up with the idea last year during the pandemic. I've always liked to work out and be active. So when everything shut down, I didn't have a place to go work out. And we were supposed to keep social distance. So running in groups or running as a social activity was no longer an option. And lastly, I didn't have a dog, so if I wanted to go running, it was gonna be by myself. And to me, that's really boring. So the next best thing that I could come up with was building my own robot. I spent about 6 months working on the project. I started out with a broken RC car that it used to belong to my brother, but he let me have it. So I took it apart and I only kept the micro servo and the DC motor because they were still fully functional. In the beginning, I built things out of cardboard, but as you can imagine, those things did not last. So I went online and got a used 3D printer. I spent a few days learning how to use it, and I started building my own parts, which made a big difference. I also experimented with different sensors, but unfortunately, they didn't work the way that I wanted them to. So eventually, I got to the PixieCam. Once I got the PixieCam, I was able to make the robot do what I needed it to do. So once I was happy with the components and where they were placed, I built a small case just to give them a little bit of protection. And now for the demo.
Thanks, Noah. I think that's certainly amazing. If anybody was looking for an incentive to get out and go for a run, I think you've just seen it there. It's an amazing piece of kit. I'd love to give that a go myself. And I should also say a big thank you to Jeremy. The examples that he makes available, it's just a wonderful contribution to the community. So thank you for that, Jeremy. So we'll now just take a look into the questions that we've got coming in from the community, and I'll hand over to Anna to ask one of the first ones.
Thank you, Kit. So the first one is for Noah, and the question is, what kind of response time / lag is with that speed of the car responding to your speeding up or slowing down while you are running?
Thank you for having me. First of all, I'm really excited to be here. So the response time, I experimented with the PID controller, as I was mentioning before. So the numbers that I assigned to each variable, to the P, to the I, and D, they have a lot to do with the response time. So it took me quite a bit of time to figure out how to improve the response in that sense. Also, the wires that I was connecting from the electronic speed controller to the motor were not the appropriate ones. So it took me a while to figure out, okay, that's a problem. I need to fix it. So then I added the correct gauge of wire, and that improved the time, the speed quite significantly. But for the most part, like the response time is pretty good. Like I can run naturally without having to worry about tripping or catching up to the car. Because if I get the closer that I get to the car, the more it's gonna speed up. So there's actually like a threshold of about 3 feet that keeps distance, and that's pretty good for me.
Wow.
Great. We've got another question coming for you, Noah. It's, have you ever considered making a drone version of this?
I did at the beginning. I told my friends what I was working on, and they said, you know what? I like to go running outdoors in the forest, on trails. So if I was to bring your car with me, it wouldn't work because there's a lot of obstacles. And they told me, why don't you make a drone? But drones, the battery won't last that long.
Wow. And a question for Jeremy this time. What kind of limitations do you encounter when doing machine learning on such small computers?
That's why I've kind of switched over to Edge Impulse. It's pretty amazing what it can do. But that's also why I like the Portenta is a little bit more powerful than many of the other microcontrollers. So you're looking at maybe 100 milliseconds to do an analysis of multiple items, which is similar to what Noel has there with the Pixie. The Pixie's pretty amazing at doing analysis of items as well. There are some limitations. I originally started with just JavaScript on a cell phone, and it has a little bit more power than the microcontrollers. And I'm still kind of up in the air about microcontrollers or cell phone JavaScript.
Yeah, and also people are asking what's the difference or benefit of pure LoRa that you mentioned?
If anyone's worked with LoRaWAN, you typically hook up to the TTN, the Things Network, or in North America, it's typically Helium. And there are 3 hash batches of numbers that you have to enter, and the device has to be nearby, and you have to connect, and it works beautifully sometimes, and other times it's like Wi-Fi in a busy area, and it doesn't connect well. With pure LoRa, it's like radio. You're just connecting between 2 devices. And it was quite a bit of effort to get the Portenta to do that, because you wouldn't actually have access to pure LoRa. I had to do some very lucky hacking there. But it's like radio. So you send out a signal, and anybody nearby within maybe up to 10 kilometers can theoretically hear that signal.
Yep.
Okay, thanks for that, Jeremy. We've got a question that's come in for both of you, actually, and it's saying, it'd be interesting to hear about the built-in functionality of the Pixie that enables Noah's project. And then also, how would Jeremy approach the same project with a Portenta? So,
can I start with that, Noah? The Pixie's amazing. It analyzes thousands of devices, gives you X, Y, width, height, and some other fancy things in like 30, it might even be 60 frames per second that it gives you hundreds of bits of information. So it's already doing massive machine learning on shades. You do run into problems if your lighting changes. With basically Noah would get a very good grade in my class. He's done an amazing project. We're actually working on something similar with machine learning with the shredder car, not the one he worked on, because I'm sure he had some issues with brushless motors and they get very complex. I'm using a different car. So we're actually doing something similar with a group of grade 8 to 11s after school project, and it's coming along. Noah?
So the reason I'm using the Pixie Cam is because I needed something quick to allow me to get my prototype up and running. I've done a little bit of machine learning myself, but I just wanted to have a prototype up and running, and eventually I would like to build a better project. So for me, I'm really interested in going towards your direction, Jeremy, about learning how to use the Portenta. I think that would, because I am having a lot of light issues, as you mentioned. When the sun is at a certain height or position, it really hits the Pixie Cam lens, and it's not usable at all.
Mm-hmm. And Jeremy, one more for you as an expert. Do you have some tricks, or would you like to share some tips and tricks for using Edge Impulse Studio together with our Arduino Portenta products?
It's amazing. It's been a long time. It's been working about 6-7 months, and it's just starting to get to the perfect stage. Something to be aware of, Arduino just produced the Nikla Vision, which I think there's something on from Edge Impulse Yawn tomorrow. The nice thing about the Nikla Vision is it has vision, it has sound, and it has motion, which are all the three main things Edge Impulse does. Edge Impulse, anyone should log in with a computer and a cell phone and go through their sound tutorial. It's a wizard. 10 minutes, and you're making a machine learning model that recognizes your voice, not other people's voices. It really is a stunning situation. I came from really quite complex JavaScript machine learning, and loading the images was a big deal. And Edge Impulse, you just take pictures. You run around taking pictures of things that aren't, oh, well, with the vision, with the sound, you just talk. So yeah, everybody should get on Edge Impulse and give it a try.
Thanks for that, Jeremy. Just you raised there about the Nicola family. Do you have any plans to do similar libraries for the Nicola series at all?
It's embed. I would assume, and I need to get mine. Mine's halfway between Arduino and my house at the moment. I've already ordered it and it's stuck. I was away the day it showed up. But I would think most of my code works. I believe it's based on embed. I have seen something interesting where it has its own kind of programming language, its potential, it has its own method, it has embed, and it has Arduino. Arduino simplifies embed and makes it so that the rest of us who don't have mechatronic engineering backgrounds can actually work with these things.
Okay, and now one question is, did you find your running improved by this project?
I did. I actually
Cool.
lost. I lost weight because when I was doing my testing, I had to go running. So I would spend maybe 2 or 3 hours running just to test it out, and then when I had it like running properly, I would run like a mile maybe, like on a single battery. I would bring a whole like 3 batteries with me in case they would run out. So I would run at least half an hour for fun before, and so yeah, eventually I ended up losing weight. So, because during the pandemic, I was actually gaining weight because I wasn't working out. So I was really happy with my results.
So we can say IoT makes you fit.
Yeah. Yes.
Yeah, I think we introduced your session with Peloton Beware. It sounds
Yes.
like Peloton and Strava Beware from what Noah's invented there. We do have another question come in from a community member just asking, Noah, what kind of sensors did you try this with before using machine vision?
So I started with what I knew how to use. I started using sensors. For example, the first ones that I tried were the sonic sensors because I knew how to use them. But the problem was that you need a hard surface to rebound the echo and measure the distance. So when you're trying to measure your feet running, it's a big problem because it's not accurate and it wasn't measuring correctly. So then I moved to infrared laser just to give it a try. It works at a short distance, like maybe 10 inches at the most. But then after that, it doesn't reach any further. So that was out of the way. And eventually, I researched and I came upon the PixieCam and I gave it a try. So that's where I'm at right now.
Okay, cool. One last question is for Jeremy, and people are asking, how do you test image classification sketches with the Portento Vision Shield? So basically, how do you preview with the camera?
First of all, the Portento H7 is the controller. You need the Vision Shield, either one. I prefer the LoRa because it wouldn't need a cable. When connected to the Arduino IDE, you'll get a serial monitor telling you the most likely chance of what something is if you've trained it for multiple items. Reminder, these things, as you go for more items that it's identifying, they have a hard time. They are just microcontrollers. And what I've done is I've hooked up a grayscale OLED to the Portenta, which much better grayscale than color. Color was way too slow to refresh. And basically you just watch what it sees. You can draw little boxes on the screen. You can put output on the screen. Yeah, so you need the Portenta, you need the Vision Shield, I used a wave share OLED, I think it was 128 by 128. And you can get a visual output, and ridiculously fast, as I said, about 100 milliseconds per frame. And all that is kind of done by the Pixie. So the Pixie, you don't actually have to train. It's identifying shades. So it's a great starting point. Yeah, more advanced, but also more complex issues when you start doing what Noel's done with machine learning. Because you're now doing all the things that the Pixie is just doing for you. And yeah, really interesting. That's where I'm at the moment, waiting for a new model from Edgid Pulse. The X and Y location stuff that Noel is getting from the Pixie is now getting fast enough on the Portenta. So things are exciting.
Thank you so much, Jeremy and also Noah, and over to you, Kate, for the last goodbyes.
Yeah, just to say thanks, guys. I think really inspirational pieces there. So all it leaves me to say is thanks to everybody who joined today's sessions. I hope you enjoyed them. We'll say goodbye for today, but please come back for tomorrow. We have a huge announcement in our Pro business that we're very excited about. It'll be a big announcement, even though it's only a very little product. So please all come back 3 p.m. tomorrow, Central European time, for the next sections of Arduino Week. So thank you, everybody.
Thank you. Goodbye.
Bye.